Hello friends, we are learning mathematical logic. In our previous video we have learned conjunction, disjunction, implication and double implication. After this we are going to learn negation of a statement. Negation. So for negation we have this sign. P and here negation of P. P may be true or false. So when P is true, then its negation is false here. When P is false here, then its negation is true, T. So this is truth table for negation. After that we have one note in case of this negation, that is negation of P is equal to the statement itself, that is P. So this is what is negation. Again we have to learn statement pattern. Statement pattern. Now let us see what is statement pattern. Statement pattern is nothing but the proper combination of statement letters and connectives. I write here in short proper combination of statement letters and connectives. Now statement letters means what? This P, Q, R also may be there. P, Q and R are the statement letters, and connectives means this and, or, implies, double implication. These are the connectives. So proper combination of statement letters and connectives is called as the statement pattern. I will give you one example. P implies Q implies P. Again we will have another examples. Second example, P and Q implies R. So these are the examples of statement patterns. After this we have to learn its statement patterns, truth table of statement pattern. What is truth table of a statement pattern? Now we will take this statement pattern and prepare its truth table. Now let us see. This one, P implies Q implies P. Now we have to prepare truth table of this statement pattern. Now first our job is to see how many constituent statements are there in that statement pattern, in the given statement pattern. Here we have P, Q, again P. That is, how many statements, constituent statements are here? Only two constituent statements, P and Q. So first we write P, Q here. Again, now in order to prepare this, we have here P implies Q implies P. Means this implies this bracket. This P implies this bracket. So in order to prepare P implies this bracket, first our job is to prepare first for Q implies P. Now when we have to prepare Q implies P, so what is in that? Q, P and their implication. So we will take their implication, but let us see. Before this we have this Q and P or not. So here before this we have this P and Q also. Therefore now we are ready to prepare this Q implies P. So I write here next column Q implies P. Q implies P. Now Q implies P, that is this bracket is ready. Now after that we have to prepare this whole statement pattern. Now we are up to what? This the last column of the statement pattern. Now we have to prepare P implies Q implies P. So before writing this or before preparing this, we will take this implies this, that is we will take their implication, no doubt. But let us see or check whether we have this P and Q implies P before this. So we have P and Q implies P also. Now I write here P implies Q implies P. P implies Q implies P. Now we have this 1, 2, 3, 4 columns are here in its truth table. Now we write entries of each column. Now first we have to write entries in this first column of P. So when two statements are there, two constituent statements are there, so there are 4 entries, and the entries of P are this T, T, F, F. That is first 2 T's and then 2 F's. After that entries of Q are now. Entries of Q are T, F, T, F. That is 1 T, 1 F. 1 T, 1 F. Now we will write entries of this column Q implies P. Q implies P. Now Q implies means this is Q implies P. Don't consider it as Q implies P. So here we have this what? Q implies P. Q implies this means what? This implies this. This implies this. This implies this. This implies this, and this implies this. Now when we have to write here Q implies P, first we should see what is there in Q implies P. So just before we have learned implication, table of implication. So see first or remind what is there in implication. So in implication, when T implies F, then it is F. Otherwise in all the 3 cases it is T. So again see in implication P implies Q. When T implies F, then we have F, and in all the remaining 3 cases it is T. So see here, now I am taking Q implies P. So T implies T, we will be here, we will have T. F implies T, it is T. T implies F. When T implies F, it is F. So I write here F. Again F implies F, this is T. Then now P implies Q implies P. P implies Q implies P means P implies Q implies P. That is P is this and Q implies P is this. So we have to take here P implies this bracket. That is this implies this. Again we have to remind in implication, when T implies F, T implies F, it is F. So see here, T implies T, T. T implies T, T. F implies F, T. F implies T, T. So this is truth table of this statement pattern. P implies Q implies P. So in this way we prepare our truth tables of the statement patterns. Now after this we have to learn logical equivalence. logical equivalence. Now first we have to see here when two or more statement patterns are said to be logically equivalent. Now just we have seen that truth table of one statement pattern. In their truth tables we have columns and there are entries in their columns. So suppose we have statement patterns P and Q implies R. Well, P and Q implies R. P and Q implies R. And P implies Q implies R. P and Q implies R. P implies Q and R. So these are two statement patterns. So we have these statement patterns. Now suppose we are asked to find whether these two statement patterns are logically equivalent. Then what we do or what we have to do. And when we can say that these two statements patterns are logically equivalent. So if all the entries in the last column of both these statement patterns are identical, same, then we can say that this statement is logically equivalent to these statements, and we write it as this statement is logically equivalent to this statement like this. So now let us see how we prove this. That is, this statement pattern is logically equivalent to this statement pattern. So for this purpose also we have to prepare its truth table. So we can find or we can prepare truth table of both the statements pattern in a single truth table. Now let us see. Now first prepare this truth table for this. That is here P, Q and R. So to prepare this there are three constituent statements. So we write first P, Q and R. So for this statement pattern also there are also three constituent statements P, Q, R. Now this bracket implies R. This bracket implies R means what? We have to prepare first P and Q. So this is P and Q. After that P and Q implies R. So our next column will be P and Q implies R. Again, now this will be the last column of this statement pattern. In the same truth table we will also prepare this statement pattern also. Now P implies Q implies R. That is P implies this bracket. Means our first job is to prepare Q implies R. So we are ready to, before this we have Q and R also. Therefore we are ready to prepare this Q implies R. That is, next column will be Q implies R. Now we have this Q implies R. P implies Q implies R. That is, P implies this bracket. Now before this we have P and Q implies R also. We have this P and Q implies R also. Therefore we are ready to prepare P implies Q implies R. P implies Q implies R. Now these are the columns of both the statements pattern. Now we write entries of each column now. Now when three constituent statements are there, so in each column there are 8 entries. Now let us see how to write entries of first column, that is entries of P. So entries of P are first 4 T's and then 4 F's. That is T, 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 F, 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 F. So these are the entries of P. Again, we have to write entries of Q. Now entries of Q are 2 T's and 2 F's. That is T, T, F, F, T, T, F and F. Again, now we have to write entries of R. In the entries of R, there are one T and one F. T, F, T, F, T, F, T, F. Now we have to prepare this P and Q. P and Q means what? Conjunction of P and Q. And now remind what is in P and Q. What is in conjunction? When we have T and T, then it is T. Otherwise, in all the remaining three cases, we have F. Now here see, this is the table of P and Q. When we have this T and T, then we have T only, and in remaining all the three cases we have F. So remind what? T and T is T, and the remaining three cases are F. So P and Q, that is this and this column. T and T, T, T and T, T, T and F, F, T and F, F, F and T, F, F and T, F, F and F, F, F and F, F. So these are the entries of this column of P and Q. Now P and Q implies R. P and Q implies R. P and Q is this column and implies R. R is this column. That is, this implies this. P and Q implies R. In implication. Now again remind what is there in implication. In implication, when T implies F, then we have F, and otherwise in all the three cases it is T. We can check here also. We have this table of implication. P implies Q. As we have learned before, that is what? T implies P. It is when T implies F, then we have F, and when T implies T, it is T. F implies T, it is T. F implies F, it is T. So remind for first, T implies F, it is F, and write down all T's in all the three remaining cases. Let us write P and Q implies R. P and Q implies R. So T implies T. T. T implies F. T implies F is this. T implies F. It is F. T implies F. F. Now F implies T. F implies T. T. F implies F. T. F implies T. T. F implies T. F implies F. T. F implies T. T. F implies F. It is also T. Now this column Q implies R. Q implies R means for this Q, this is column of Q and this is column of R. Q implies R. T implies T. T. T implies F. F. F implies T. T. F implies F. T. T implies T. T. T implies F. So it is F. F implies T. T. F implies F. T. Now we have this last column now. P implies Q implies R. P implies Q implies R means what? The column of P is this and column of Q implies R is this. Now this T implies T. We have T here. T implies F. We have F. T implies T. T. T implies T. T. F implies T. T. F implies F. T. F implies T. T. F implies T. So it is T. Now these are the entries of our last column. Now we make it stable. Now this first statement pattern P and Q implies R. Its column is this and entries are this. After that, P implies Q implies R. This column and these entries. Now check the entries of these statement patterns. TF, T, 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 T. Again, TF, T, 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 T. Means what? All the entries in the columns of both the statements patterns are identical. Therefore, this statement pattern is logically equivalent to this statements pattern. Now, how we have to write this? These are the columns first, second, third, fourth, fifth, sixth, seventh. And we write it as all the entries in the columns. In the columns, which columns? Fifth and seventh. Fifth and seventh. All the entries in the columns fifth and seventh are identical. Therefore, the given two statement patterns are logically equivalent, and we write it as P and Q implies R equivalent to P implies Q implies R. Now in this way we will show the logical equivalence of the given statement patterns. After this we will learn tautology, contradiction and contingency in our next video.